Welcome everyone. Today we will learn about these kinds of topics. Are firstly, what is elastic deformation and plastic deformation. Secondly, the elastic limit. Thirdly, the force extension graphs. And lastly, the calculation of elastic potential energy. So let's just dive into it. So what is elastic deformation? It is when an object returns to its own original shape after force is removed. So just thinking of there is a rubber band, so just thinking of stretching it and just letting it go. It will go back to its own original shape. So it's the same with the spring. There is spring, stretch it, and let it go. It will go back to its own shape, the length. So this is elastic deformation. So what is plastic deformation? Is when an object does not return to its own original shape after the force is removed. Imagine there are a piece of clay. After you remove the force, it won't come back. It won't come back, right? It just stays bent. So this is plastic deformation. So this is the difference between these two kinds of deformation. So next is elastic limit. Elastic limit is maximum extent to which a solid can be stretched without permanent deformation. Like, beyond this limit, the material will undergo plastic deformation, but after breaking down the limit, it won't go back to its own original shape. So what is next is the force extension graphs. But before this, I think we have to know something about the background knowledge is Hooke's law. Force is equals to kx, which states that the force is proportional to the extension x. When a small force acts on an object to move it a small distance. Yeah, so work done is given by what? F dx. We all know this, right? So, okay, for now we can talk about the force extension graphs. For the y-axis is force. For the x-axis, it's extension. So we have the formula of this. So we all know it's a linear graph, right? Up to our limit. And after that, it won't be linear, I think. Using Hooke's law, we can substitute f into the work equation, right? And to find the total work done, which also is essential potential energy, elastic potential energy. So we need to sum up all the work from x0 to before the limit x, right? So this is done through integration, like and what does it mean? It means the under area of this graph. So this represents the potential energy, also the work done. So how to compute the integral? We all know this. We all know this can right as like we know this part, right? So we know right? So it will be from x, from 0 to x. Yes, so it will be equals to, yes, and this is how potential energy come out. So it's potential energy equals to, yes. Let's use an example to solidify our understanding. Okay, so suppose a spring is stretched by 0.2 meters with a spring constant of 50 K per meter, 50 Newton per meter. So we will calculate the elastic potential energy as follows. Equals to Joe. Yes, this is the answer. Today we learned about elastic and plastic deformations, elastic limit, for extension graphs, and how to calculate elastic potential energy. So if you have any questions, just ask. Don't be shy.